We go to another reaction. That is the fourth reaction now. The fourth reaction is decomposition reaction. Decomposition reaction. Decomposition reaction is a breakdown of a compound by application of heat. That means anytime you break a compound by the application of heat, you call that decomposition reaction. But decomposition reaction is divided into two. That means if we are looking at decomposition reaction, which involves the breakdown of a compound by application of heat. That breakdown of a compound will now be put into two. That means there are two types of decomposition reaction. The two types of decomposition reaction now that we are going to look at are: one, Tamar decomposition reaction. Tamar decomposition reaction is the first type of the decomposition reaction. It is now Tamar decomposition reaction. Now let us look at Tamar decomposition reaction. Tamar decomposition reaction is a reaction in which you apply heat to a compound, the compound breaks. But when the compound breaks, the product that are produced will not combine to form the original compound again. I go over that statement. Tamar decomposition reaction is a reaction in which heat is applied to a compound. The compound breaks. The new compounds that are formed, when the compound breaks, the new compounds that are formed will not combine to produce the original compound again. That means the moment they are produced, they will not combine again to form the original compound. So what I mean by that, if you apply heat to a compound AB, this one is the symbol for the heat, the triangle on top. So when you apply heat to compound AB, let us say compound C and compound D, they are produced. But even when you remove this heat, compound C and compound D, they will not combine to produce AB again. So a reaction of that type is known as Tamar decomposition reaction. That means heat is used to break the compound. But when you remove the heat, the compounds that are formed will not combine to produce the initial compound again. So that reaction becomes Tamar decomposition reaction. Let us get an example for Tamar decomposition reaction. If you take calcium triocarbonate 5 this way, CaCO3, you apply heat on this compound, you are going to produce calcium oxide, CaO, and carbon 4 oxide. That one will be the reaction. If calcium triocarbonate, you apply heat. The triangle here tells you that heat is applied. If you don't want to write HEAT, you just put this one. You are going to produce CaO and carbon 4 oxide. That means calcium oxide and carbon 4 oxide. So if you have a product this way, calcium oxide and carbon 4 oxide, you call this reaction Tamar decomposition reaction, simply because even when you remove this heat, this calcium oxide and carbon 4 oxide, they will not combine again to produce this compound here. So a reaction of that type is double Tamar decomposition reaction. Second form of that, we can also write lead triosonitrate 2. You can get lead triosonitrate 2. When you apply heat on this compound, the compound breaks to produce lead oxide plus nitrogen 4 oxide plus oxygen. Now when we want to balance the reaction, maybe you can balance the reaction, you put 2 in front of this, you put 2 in front for 2 leads. Now we can put 4 molecules here, because we have nitrogen 4, 2 here plus the 2 here becomes 4. We can put that in front, and we can also put 2 in front of the oxygen here to balance it. So when you apply heat to this compound, the compound breaks to produce this compound, and this compound. So that becomes Tamar decomposition reaction. The compound breaks to produce 3 compounds here, but when you remove the heat, this compound will not combine to produce it. So it becomes Tamar decomposition reaction. Since it is a Tamar decomposition reaction, we go to the second form of the reaction. And that reaction is Tamar dissociation reaction. The second type of the decomposition reaction is Tamar dissociation reaction. Tamar dissociation reaction. For Tamar dissociation reaction, a reaction is said to be Tamar dissociation when heat is applied to break the compound. But when the heat is removed, the compounds will combine to produce the initial compound again. That means heat is used to break a compound. New compounds are formed. When you remove the heat, those new compounds will combine to produce the initial compound that was heated. So if that is the case, we can get an example of ammonium chloride, NH4Cl. You apply heat on this compound. When you apply heat on this compound, you are going to produce ammonia, NH3, can say CN. So for Tamar dissociation reaction, heat is applied to a compound. Like we apply heat on ammonium for ammonium chloride, the compound breaks to produce ammonia and hydrochloric acid. But when you remove heat on this, these compounds will combine again to produce the initial one. So hence we represent that by two arrows. One is going to the right and one is coming to the left. When you see that, that is the difference between Tamar dissociation and Tamar decomposition. For Tamar dissociation is also an equilibrium. That means there must be two arrows, one pointing to the right and the other one points to the left. We also have the right to say you apply heat, let us say on this compound here. Again, that is Tamar dissociation because of two arrows pointing. Heat is applied to break the compound and the compound breaks to produce nitrogen oxide. When you remove heat from this compound again will combine to produce this one. So that is Tamar dissociation reaction. A Tamar dissociation reaction is a reaction in which heat is applied to a compound, the compound breaks. Upon removing the heat, the compound now recombine to produce the initial compound. That becomes Tamar dissociation reaction. See.